Hello everyone, my name is Gomanth and my paper title is Blockchain-Based Firmware Security Check and Recovery for Battery Management Systems. My co-authors are Justin J. Ochoa, Dr. Taisik Kim, and Indrasena Reddy Enugu. We are from Cyber Physical Power and Energy System Laboratory, Department of Electrical Engineering and Computer Science, Texas A&M University, Kingsville. The contents I would be presenting today are Introduction, Cybersecurity, Reverse Engineering, Proposed Method, Experimental Results, and Conclusion. What is BMS? Battery management systems perform a crucial role in many electronic and electrical system-based applications, such as onboard condition monitoring, fault diagnosis, control, and optimization. BMS are crucial for optimal performance and reliability of many devices and systems, including the transportation systems. You can see the Tesla model there, the car, and the battery energy storage systems, BESS, like the Tesla Powerwall 2, and the portable electronic devices like the iPhone 11 Pro Max or any other phone that we carry today. They all have the batteries and some management systems within them, so BMS. What is blockchain? Blockchain is as old as internet, but blockchain is used in different cases. Blockchain can be used for cryptocurrencies. Blockchain can be used for digital ledger technology. But we are using blockchain for distributed ledger technology. Let me give a brief idea about the blockchain. It consists of the timestamp blocks linked to each other by a cryptographic chain, which is called, in total, it is called as blockchain. Each block has data with numerous transactions. The blocks are inherently resistant to tampering and revision. The blockchain is hosted, updated, and validated by individual peers, nodes, rather than as central authority. This will really help us in achieving the single point of failure problem. You can see a sample transaction T1 there. ID is equals to the BMS01 and timestamp is something, and all the voltages of each battery are displayed in a transaction, which is a sample transaction. So you can see the blocks there. The B is a block, and H is a header, and D is a data, and M is a metadata. So these blocks are linked through cryptographically. So these are a few features of the blockchain: cryptography, timestamp, trust, anonymous, distributed, program, immutable. Transactions are encrypted by cryptographic keys. Only participants that have keys can verify the data and the users of the transaction. What is Hyperledger Fabric? First of all, what is Hyperledger? Hyperledger is an umbrella project of open source blockchain and related tools started in December 15 by Linux Foundation. IBM's Hyperledger Fabric is the one which we implemented in our testbed environment. And what are the benefits of the Hyperledger Fabric? Actually, basically, the blockchain can be private, permission, and permissionless. But the Hyperledger Fabric is permission and private blockchain, providing us the access control. So we know who exactly is in our network. And it requires less energy and less computational requirements for consensus, which means for validating a transaction. And does require transactions, that doesn't require any transaction fees or any coins like Bitcoins. So this is totally different. Introduction, firmware security. Firmware security is of paramount importance to be considered when designing an embedded BMS board operating in a cyber physical environment. Any modified firmware can result in wrong control actions which lead to a disaster. For example, in 2019, several lithium-ion battery energy storage systems in Korea caught fire. Wrong SOC values were provided to uninterruptible power supply, which is UPS. So resulting in batteries that kept overcharging. Although this case might not be caused by either cyber or physical attacks, but it is possible that hackers, by manipulating the firmware, these kind of disasters can happen. In 2011, a security researcher modified the firmware of an Apple MacBook battery system through the physical access of a wired communication channel. This is a case of physical attack to the BMS, and tricking the BMS battery, the Apple MacBook battery, to report a low charge, even if it's having a high charge, it's fully charged. As a result of this firmware vulnerability, the charging circuit allowed the MacBook battery to overcharge until the device was bricked. And this case shows the security concern, which is still prevalent even without the internet access, which means the counterfeit EV BMS can violate the both mechanical and electrical safety requirements related to the short circuit protection, charge safety, and provide wrong information. So even using the blockchain technology, if the firmware has not been taken care, has not been checked, you get a wrong data and everything goes wrong. So cybersecurity, BESS can impose an increasing amount of threats from cyber attacks, such as security and safety risk with malicious intentions. An investigation of these potential threats can lead to solutions for prevention, mitigation based on the corresponding issue. So you can see that Tesla Model S has been crashed. That might be for any reason, but battery firmware can also be one of the reasons which could lead to a crash. So cyber security service, in order to understand the cybersecurity service, we have divided the conditions to network vulnerability, data storage vulnerability, software and firmware vulnerability, and onboard interface vulnerability, the hardware vulnerability. So we are most considered about the firmware vulnerability. So we did reverse engineering to study the firmware, how it is secure in the BMS devices which are being provided by the Texas Instruments. So these three green boards are the BMS boards from Texas Instruments, and the black boxes which you can see at the top right corner are the EV2400s, which are helping us to connect the board to the IoT device. And the IoT device which we are using for our setup is Latapanda. And each battery pack is having 5 cells, and each board is connected to the electrical load, which represents a fully connected network circuit. And for the purpose of reverse engineering, what we did is we actually investigated the firmware of the TI, and we actually tested it by manipulating it in 2 ways. One is manipulating it to a small extent. So when we manipulated the firmware to a small extent, the BMS unit could not detect it. The software BQ Studio could not detect the change. So that is potentially risky. And the second type is firmware has been changed to a large extent from the original one. Then the whole BMS unit has stopped working. Even that is really a security problem, because when a hacker tries to change the firmware, the BMS device gets totally communication lost. Even that is a successful attempt for the hacker. So you can see the 2 screenshots of the BQ Studio software, which is reading the values from the BMS unit. The left side one is a good working one, and the right side one is the one we can see after the BMS board has been bricked, and it could not be recovered at any cost. So we have observed that this kind of potential firmware vulnerability is possible in the BMS board, and then we proposed a firmware security framework. And the architecture of this is right here. To the right, you can see the image. Blockchain-based firmware security check and recovery framework. And we have the battery energy storage systems, that is the BMS boards. So each BMS board will act as a participant with the help of an IoT which is connected to that board. So every time, what happens here is, you can see the flow chart. Every time the BMS unit will collect the firmware hash and the firmware version from each BMS unit. So every BMS will generally have a firmware in it, and we are trying to calculate the hash of that firmware along with what version. Is it version 1.0? Is it version 2.0? Like that. And we collect the data and we send it to the blockchain. And in the blockchain, we will have the original firmware value with the help of, you can see the middle one. It's a BMS, protected BMS. This is called as protected BMS. Protected BMS is the one through which we enter the information which is true. Like original firmware is entered through the protected BMS, and the other BMS are used for the testing purpose. So in the original protected BMS, we have the original hash, and in the normal BMS in the network, we have the current firmware on it. So we take the firmware hash, we take the firmware version, we compare it. So if the firmware version matches, that's okay. We set the authentication to yes. If the firmware doesn't match, we just update the firmware file which is in the each BMS unit. So that is a part of recovery. So this algorithm shows step by step that collects the values and calculates the firmware hash. We are using the hash SHA-256, and we are sending the firmware hash and firmware version to the blockchain. In the blockchain, the comparison happens, the firmware hash and also the firmware version. And then if it is found that it is okay, then the authentication is set yes. If it is found that it is not okay, then the new firmware is being downloaded in every BMS, which has to be recovered, and then it will be recovered. So for the purpose of testing, we have not used TI's firmware because which is not public, and we are limited by the BQ Studio. So we have not used the BQ Studio, we have not used the TI materials. So we created a firmware by our own, which we considered it as a original one, and we manipulated that file and we considered that as a manipulated one. So right now we have original firmware and manipulated firmware, which is created by ourselves. I mean, we created it. So this is a smart contract. You can see that a participant will have name and type, and the asset will have the firmware hash, firmware link, firmware version, and authentication. So this is actually a smart contract from which you get the information to the blockchain. And you can see here, there is a transaction firmware check. There is a transaction which says send firmware info. There is a transaction which is called recovery. So first send firmware info will happen, and then firmware check will happen, then firmware recovery will happen. So for the testing purpose, we took 3 BMS units, BMS1 and BMS2. BMS1 and BMS3 having the original firmware which we created, and BMS2 is having the manipulated firmware which we actually changed from the original one. So as you can see that the BMS2 is having a different hash because we actually have the manipulated firmware on it. That's why the authentication is no. So what we did is we used the proposed network and we tried to do that. So whenever it got authentication no, it automatically downloaded the new firmware, and then the hash is also updated and the version is also updated, and you can see that now the authentication is yes. So before using any real-time data, we have to do this firmware security check, recovery, and patch generation, so that our data will be correct. So this paper provides the reverse engineering that shows the prevalent firmware vulnerabilities of the current BMS board, as well as a novel firmware security check and recovery framework using the blockchain technology that has been proposed to mitigate potential security risk from hackers. The experimental results validate the proposed framework, and that can enhance the framework security of the BMS, embedded BMS in electrical vehicles, especially in cyber physical environment. Furthermore, the proposed method can be applied to other cyber physical systems, including the IoT-enabled electronic devices, power electronic devices, and systems such as smart solar inverters and microgrids. So this is the architecture. We have the BMS, which are the participants, and they communicate to the framework. And this is a flowchart. So for the testing purpose, what we have done is we have one protected BMS through which we send the original firmware to the blockchain, so that blockchain knows what is the original firmware, and the other 2 BMS are just as normal every BMS. So this normal BMS will send the firmware what they have, will send the hash of the firmware what they have. So this in turn is checked with the original firmware which is in the blockchain, and then if it is yes, if it is good, it is authentication is set yes. If not, the recovery will happen. Yes. So this is before using the proposed framework. So there was something found that there is no correct firmware. So that's why the update of the firmware has been happened, and now we can see that the proposed method is working, and now we have the firmware integrity with us. Yes, this provides the novel firmware security check and recovery. So this can be applied to any other systems as well. So even we can have the over-the-air updates using the protected BMS. The protected BMS can keep updating the firmware and its version. So the updated firmware version will be compared with the firmware on the other BMS. In that way, the firmware integrity is maintained. Firmware security check and recovery is being achieved. Thank you for this opportunity.